Well, hi, good morning from my shop of terror here. Today is September 16th. So I've just finished an hour and a half of brain twisting effort trying to align this radio, and I've introduced a new piece of equipment in my shop to try to help things out, and that's this FeelTech frequency counter, which is why I initially purchased this. This sits in another place in my house. You see, this is such modern technology, it scares the daylights out of all the other stuff in my shop. So I don't bring it in here, I don't let them ever see it. But it's in here now because I'm having trouble with this signal generator and my sweep generator I was using. So if you're just tuning in to watch the FeelTech thing, there's going to be a little bit of talk in what you're going to say, what you're going to see next about the radio and what I'm trying to do. But one of the first things I did, and what you're going to watch, is me checking this guy out to see if there's any dangers in using it. And why would I think there's some dangers in using this? Because of this. A two-prong plug, no third prong. What's going on with this guy? I know others have discovered that there's some voltage on the terminal here. I think it's just a capacitive leak. I don't think it's anything serious, but anyway, I did some testing on this, so that's what I'm going to present today on my channel, is my leakage testing of the FieldTech. So sorry it's not going to be as clean a video. Well, they never are they, when they come from me, because it's all done essentially live and on the spot. So I'm just trying to salvage something to give you to watch. So this is all about the FieldTech. It's a FY3200S dual channel arbitrary function signal generator / counter. Two outputs, two separate signal generator outputs here, and one input for the counter. Anyway, I hope this works out. Have fun watching this. So, introducing a new piece of equipment, even one as modern as this. I'm a little hesitant at first. One of the things that's made me a little hesitant about this guy is, believe it or not, it's a two-pronger. Hey, look, there's no holes in the prongs. What's going on there? Prongs have holes. How can you have no holes? So these holes go back, way back to early attempts to kind of lock the plug into the outlet, to make the outlet grab the plug. Some kind of indent or bump would grab these holes. That's what the holes are for. So first thing we're going to do is we're going to check the leakage current on this, since I've heard on a video that there's some concerns about the plugging this in, and this is not floating at zero. The outside of these not floating at zero. Check this out though. You put it in, it drops out. No holes. and just can't even feel it. I don't think it's the holes. That's not coming out. I have to pull it out. Okay, something to keep in mind. In it goes. Now I've plugged it into here. This is being fed, it's a little bit unnecessarily complicated, through a isolation transformer into this box here, and I'm sorry about all these wires in the way. And so with this I can control the line or the supply voltage quite nicely, all the way from 0 up to, I think, over 120. It says isolated output here. You can see I'm plugged in with a 3-prong plug, but what finally makes it to my bench is just 2 prongs. So this third prong, don't be fooled, it's just sticking out there. And that's just a 2-prong extension cord. So I'm trying to avoid grounding my projects. Most of the things I work on are 2-prong devices anyway, they're not 3-prongers. So this guy has the ability to measure leakage current in very small amounts of leakage current. not terribly experienced at using it, but let's try it out. Okay, so this is a special leakage probe. Plug it in. Set this to output. This shows the voltage. Let me pull this out of here. Flip this on. No dim bulbs involved. 121 volts is what it says there. Nice red line there at, I think, 117. There we see 118 on here now. That's good. That's a good voltage. And we set this to leakage. There's a low side and high side. I'm not totally clear on what they mean by that. So I'm going to plug this in. It's now my little FeelTech over here is now energized. And what I'm going to do, I'm just going to hold the probe on here. And then we're going to watch the meter. Let's see what it does. Darn wires. We'll try low side leakage first. So this comes with a little button. Push to read true leakage current. So maybe you get an initial test, and you push this to really sensitize the meter. Let's see. Okay, so I don't see any movement on there. I'll push that button. No movement whatsoever. Hoping I'm doing this right. Flip it on high side, touch it. There's a little leakage there. The meter is going up. I'll push the button. And it seems to me to be exactly the same reading. It makes me wonder, does the button work? So what is that reading? It's hardly coming up the meter. Okay, so on the leakage scale, it's in microamps. Put it on there again. I'm reading 50 microamps. Nothing there. I'm going to reverse the plug. This doesn't quite make sense. This is the power supply in this unit is a switching power supply. Oh, now we see it. Okay, same reading. I'll push the little test button. Nothing happens. About 50, maybe even 75 microamps of leakage. 75 microamps. That's 75 millionths of an amp. That sounds like you couldn't even feel it if you wanted to. Let's take a look at the voltage here on this unit. This is more typically what I do. Check voltages between things I've never connected before. Even when I'm pretty sure there shouldn't be any voltage there, this is going to come out. I'm going to leave that out for now. So I'm going to plug this into a power bar here, which is basically right into the outlet. There's no grip on this plug at all. It's just ready to just bump it and it'll fall right out. Oh, you know what I didn't do? Well, hold on, I missed something. Let's go back to here. Turn it on and test it. That would be a good idea. Now, here's the problem with this in my shop is all you'll ever see is a bright screen there. You'll never be able to read it. That's fine. I'll just explain what it says when I have to. Grab the probe again. I really don't expect there to be any problem here. It's just someone on the internet was complaining, so okay, same test to the ground. Nothing showing up. That. Same leakage. What exactly it is that's leaking, we don't know. It could be although it says leakage, it could be just a capacitive effect. Having all that stuff together in one box, there's inevitably a capacitive connection, if you like, between everything. Okay, I think we're good to go except for the voltage measurement. Oh man, that's really terrible. It's really a terrible plug. So voltage measurement, we'll do it with my digital meter here. This is a very high impedance meter. It's not going to draw off of this much. Microamps, you know what, this might actually draw enough enough to make it not possible to see the voltage. Put it somewhere where you can see it quickly, man. Get my helper here. Okay, that's reading AC volts. Go from here to a grounded thing. 44 volts. So that's an eye catcher for sure. I wouldn't want to ignore that. But I think it's 44 volts with no oomph behind it whatsoever. Okay, just reverse the plug. 44 again. I was kind of figuring I'd see the other half. 44. Again, I think it's just a capacitive effect. But you know, when I'm working in big old tube radios, doesn't matter at all. But working on a transistorized unit, especially if it's got sensitive transistors in it, maybe that would cause a problem. So the way I'm going to solve this, I'm going to waste one of my leads here. So this is an input, so this can read the frequency here if you want to use it as a frequency counter. And these are two outputs here. Each one's completely independent and controlled independently. Two signal generator outputs, different kinds of waveforms, all kinds of stuff can come out of here. Of course, I'm just after a sine wave. The beauty of using this is I'm going to tell it to produce a 10.7 megahertz signal, and it's going to do it right on the button. I'm not going to have to worry about it being a little off and all that kind of stuff. That was literally driving me nuts with the equipment I was using. So I'm going to sacrifice one of these, turn it into a ground lead. You know what? There's some terminals on the back here. TTLA and TTLB. So it's transistor logic levels out the back here. Would it matter if I use this? It has a ground symbol there. And I notice on the front it also has ground symbols. I don't know what those mean because there's no ground. This is a two-prong unit. There's no ground. Two-prong unpolarized plug. So is this an instruction? You need to ground these? Okay, so this will be the ground lead coming off the back of this, and I'm going to just clip it to something that is securely grounded here, where it won't get knocked off. Right on here. So, if there was a little voltage pressure on this thing, it's gone now, relative to everything that's grounded. Now, this guy's also a two-pronger, but he's got a polarized wire on it, but I'm sure originally it wasn't polarized. It's got similar problems, but I have a ground on this. This clip is going right back to a ground terminal over yonder. So that's how I'm going to maintain. I don't really think my safety's at risk here. I think it's just risk to the equipment. So we're ready to go. We're safe to go. Let me stop a bit, get some coffee, and we'll start to work here. So my thinking here is I bring in a unit like this, brand new, oh, not really brand new, but should be working 100%. So I thought, well, why don't I just, before I put it to work, take the output here and take a look at it on the scope and just see that the voltage it says here, which I know you can't see, is what shows up on the scope. So the voltage here is set to 2 volts. It's a little awkward here, but this is what I gotta do. Make it visible. 10.7 megahertz, 2 volt sine wave. 2.0 volt sine wave. On my scope, that is just connected straight to the scope leads. There's nothing else going on. So fed directly into my oscilloscope. The scope is set to 1 volt per division. What's happening? How come this isn't quite a division here? Less than 1 division. This guy says it's less than a volt peak to peak. It's peak to peak. Whereas I'm sure what's on the 2 volts that are being stated on the generator is going to be RMS voltage. So this should be like that. Now I've got my vacuum tube voltmeter going here too. This is at 10 megahertz. It's probably out of the range of my voltmeter, but I'm just going to touch my voltmeter lead to the output of the signal generator. You see what's happening on the scope? Okay, so my voltmeter is going up a little bit. This is an AC measurement, so the input impedance on the VTVM is lower than it would be with DC. There's a little switch on the probe I have to throw to, which I've done. Well, that is suggesting to me what's going on here is the meter with its high input impedance, and maybe even the scope, is pulling down the output voltage of this little guy here. He's trying to put out 2 volts, but he can't do it. Now if I flip my probe is on times 1 right now. If I flip it to times 10, that's interesting. Times 10. Okay, so we'll multiply this by 10. This is now 0.1 volts per division, and my probe impedance has gone way up. So this should still be 2 volts here. So 0.1, if it's 0.1, it would be 1, 2, 3, 4, 5, 6, 7, 8. It would be like 3 times the size of this screen. Put the voltmeter on again. It's knocking it down the same way it was, getting the same reading off a voltmeter. And I'm going to try all this at a lower frequency. Just take me a second here to do that. We'll drop it down to 1 megahertz. 1 megahertz now. We have a 1 megahertz. Well, I wasn't looking at the scope. You know, I can look right at the scope and do this kind of stuff. You see, it is dropping a bit. Down to 1 megahertz sine wave. The output voltage is still 2 volts. It's terrible. That's just horrible. Who to believe? I think you have to believe the scope. I really thought, gee, I just read the number on the thing and there you are. How do you like that? Everybody's against me. Everybody's against me here. Just quickly looking around to see what stupid thing I'm doing. I'm not doing anything stupid here. This is all quite sensible. That's at times 1 right off the screen. Voltmeter. Oh, the voltmeter's not drawing it down very much. It's not moving on the scope now. What happened there? Okay. So, voltage that I'm reading on my meter now, AC volts with a setting of 2 volts on the device. My meter reads all of it's just under, no, 1.5, wrong scale, Jim. 0.55 volts. 0.55 volts. Now does that compare to this? .1 per division. 0.15. 0.15. This is all over the map. Who's lying here? Oh my gosh. That's that old thing, you know, the guy with 2 watches never knows what time it is. That's kind of where I'm at here. Son of a gun. Okay, so what I've learned is I don't know what the voltage coming out of the FeelTech is when it gets to the project. I don't know. Oh my gosh, it's just, it's probably not a critical factor. Maybe I don't have to set the input voltage, except I have to set it to a discrete value or something. Oh my gosh, okay. I'm going to stop, drink some coffee, and just ponder the situation here before I continue. Well, thanks a lot for watching that short video about the FeelTech. What I'm really doing here is trying to align this radio. And the reason you're not seeing videos of me aligning it, including using this device, is because it's a thumbs down situation. It's not working out. So I'm left pondering if there's something actually wrong with this receiver, or if there's something wrong with my setup, or if there's something wrong with me. That's where I'm at. That's why I'm not posting videos of the actual work I'm doing. So until I get something to work really well. So thanks a lot for watching that, and keep your fingers crossed that I can get through this situation. Thanks.